Okay, so let's finish this up. If you look at the embryos of these different organisms, okay, notice the spine and the tail. Every one of them have a spine and a tail. They have a head, you can see eyes, you can see other things that are forming through the embryos. As the embryos turn into fetuses, you notice that the fetus is starting to differentiate and become more like the organism will be when it is born. Okay, and then once the organism is the fetus is at its almost fully developed stage before it finalizes after birth or before birth, you can definitely tell those differences. So here is a cow, okay, versus a chicken. Notice the difference in the embryos of the cow and the chicken. They look almost identical. It would be hard pressed for you to be able to tell a big difference. Even as they start to develop through the fetus or the embryo starts to develop, you can see that there's not that big of a difference. Not until you get to that point to where the differentiation is almost complete can you tell a difference. Here's the fish. Here is us. Okay? Look at our embryo versus that of a chicken or that of a cow. Almost identical. Okay, almost identical. There is some differences between ours and the fish, but you can still see the similarities. Look at our embryo, still has a tail. Okay, you really can't tell what it is until the fetus is almost developed. Okay, so we do have those similar structures. Here's a turtle, a pig, salamander, rabbit. Okay, very, very similar characteristics through embryos. Okay. Okay, so that's going to wrap up our evidence. Okay, the different types of fossils, mold fossils. There's a cast fossil. There's trace fossils, like imprints, footprints. The molds would be like the bones that you see for like dinosaur bones. You have the amino acid sequences that we looked at. You have comparative anatomy like homologous structures versus vestigial structures. And then embryological evidence, looking at the relatedness on the similarities between embryos of organisms.